Part D in this section is about coin problems. There are lots of different forms that coin problems can take, but they all end up in more or less the same format. Our first sentence will include the variables for the number of each type of coin, the number of dimes and the number of nickels. Our second sentence will deal with the value of the dimes and the value of the nickels, which add up to the total value the coins are worth. Let's write our first sentence. Jennifer has $2.45 in dimes and nickels. That means the value of the dimes and the value of the nickels add up to $2.45. But what is the value of the dimes and the value of the nickels? Well, the value of one dime is 0.10 cents. But we need to know what the value of all of the dimes is when you add them all together. If one dime has a value of 10 cents and two dimes has a value of 2 times 10 cents or 20 cents, three dimes has a value of 3 times 10 cents or 30 cents. So a certain number of dimes has a value of D times 10 cents, or 0.10 D. This is multiplication. So the value of all of her dimes is 0.10 D. We just don't know what the D is. We don't know how many dimes she has. It's the same for nickels. One nickel has a value of 5 cents. Two nickels has a value of 2 times 5 cents, which is 10 cents. Three nickels has a value of 3 times 5 cents, which is 15 cents. So n nickels, an unknown number of nickels, will have a value of n times 5 cents, or 0.05 n. The value of all of her nickels is 0.05 n. We just don't know how many nickels that is. But if I add the value of all of her dimes and the value of all of her nickels, I get a total value of $2.45. So there's one of my sentences. Let me clean that up a little bit. I'll rewrite it up here and get rid of this version. There's something else we know about these coins. She has 8 more dimes than nickels. Translating that, I can say that the number of dimes that she has is 8 more than the number of nickels that she has. So now I have another sentence. D equals n plus 8. Here are my two sentences. Notice that D can be written as D, or it can be written as n plus 8. So let's take this sentence down here and rewrite it. 0.10 D plus 0.05 n equals 2.45. But instead of writing D, I'm going to replace it with n plus 8. N plus 8. And I've done that, as I've done this with any of the previous problems, because replacing one of the variables with its other value means that my sentence now only has one letter in it. Up here I had two different variables in this sentence. I can't solve that for either one. But if I replace one variable with its value in terms of the other variable, then my new sentence only has one letter in it, in this case n. So now I can use all the techniques from Chapter 1 and the beginning of Chapter 2 to solve this equation. Okay, once again I have distribution. So this sentence becomes 0.10 times n plus 0.10 times 8. I can do that on the calculator, and I get 0.8 plus 0.05n equals 2.45. Now I can combine like terms. 0.1n plus 0.05n, or 0.10n plus 0.05n, is 0.15n. I'm adding the 0.10 and the 0.05 to get the 0.15, plus 0.8, no n here, equals 2.45. Now I have one term with a variable in it and one term with no variable in it, the constant term. That's in my way, so let's subtract it from both sides. Subtracting it from here means that on the left-hand side I'm left with just 0.15n, and on the right-hand side I have, well, let's see, I can either do 2.45 minus 0.80. I can do this subtraction. So this arithmetic yields 1.65. Okay, let's move this up here and continue. I have 0.15n equals 1.65, and the number stuck to the n by multiplication is 0.15, so to get rid of it, I need to divide by 0.15. Any number divided by itself is 1. I'll just do this on the calculator. This result is 11. I don't need the n, so n equals 11. That's not really my solution, but it's part of it. Since n represents the number of nickels, I now know how many nickels she has. But I'm asked how many of each coin does she have. So now I have to figure out how many dimes she has. The thing is, I know that the number of dimes she has is 8 more than the number of nickels. So rewriting this expression and replacing n with 11 gives me d equals 11 plus 8, which is 19. So she has 11 nickels and 19 dimes. Your textbook takes a different approach with this. Again, it doesn't try to come up with two sentences. The algebra we end up doing is the same, but your textbook jumps to this step and does this substitution without really explaining where it's coming from. You don't have to write the two sentences out like this. I think it's very helpful. The other thing your textbook does differently is it moves all the decimal points in this sentence 2 places to the right, so that it's not working with decimal numbers at all. When you do that, you end up with 10 times n plus 8 plus 5n equals 245. So basically we're just working in cents here instead of dollars. 0.10 is 10% of a dollar, the value of 1 dime. 0.05 is 5% of a dollar, the value of 1 nickel. If we move the decimal point so that we're talking about 10 cents and 5 cents, then we also have to be careful to move the decimal point here. $2.45 is the same as 245 cents. So instead of $2.45, I'm now talking about 245 cents. When I do this problem, I do it the same way. Combine like terms, subtract 80, divide by 15. The result of this is n equals 11, the same answer as I got the last time. And of course, you still need to do the substitution as well. Which approach you take is entirely up to you. Everyone thinks a little differently, and even among mathematicians, everyone works a little differently. What's important is that you understand the concepts, the things we learned in Chapter 1, the distributive property, the commutative property of addition, and early in Chapter 2, the addition property and the multiplication property of equality, and use them correctly.